Hey everyone, welcome back. Today we are solving count collisions on a road. So the problem basically states that there will be a road filled with n cars and each car will have L, R, or S. L means it's moving left, R meaning it's moving right, and S meaning it's just staying, so not moving right nor left. And each moving car will have the same speed. And we basically want to find out the number of collisions that there are. And it tells us here that if two cars moving in opposite direction collide with each other, then we increase collisions by 2. So meaning if one is going left and one is going right and they crash, then we increase by 2. And if one car hits a stationary car, so if a left or right car hits one with S, then we only increase the number of collisions by 1. And it tells us that after a collision, the cars can no longer move and will stay at the point where they collided. Other than that, cars cannot change their state or direction of motion. And finally, we want to return the total number of collisions that will happen on the road. So if we look at this example, we return 5 because there's one collision here, one is moving right, one is moving left. So that would be 2 because increase by 2 if it's opposite direction. And R hits S here, that's one more. And L hits S here, so that's another one. And L hits S here again, so that's another one. So the total will be 5. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we will be using a variable called state. And if state is a negative number, then that means the car traffic is moving left. And if state is 0, it means no cars on the left are moving right nor left, meaning the traffic on the left would be a staying position. And if state is a positive number, then that means states represent the number of cars on the left moving right. So in other words, it would be the number of collisions if the current car is staying or moving left. So now knowing what state stands for, we will iterate through the string directions, so the input string. And let's say if the current string is L, then we need to add state plus 1 to result and reset state to 0, assuming that state is greater than or equal to 0. So let's say the cars on the left are moving right and the current car is moving left, and there will be a collision. And because if opposite direction collide with each other, we increase by 2. So that's why there's a plus 1 here. And if state happens to be 0, then we will just add 1 because it'll be 0 plus 1. And if state is less than 0 and the current car is left, then it's just another car moving left and there's no collision. So that's why we only do it if state is greater than or equal to 0. Now, if the current car is staying, we will add the value state to result if state is greater than 0. So that's the number of cars moving right. And we will reset state to 0 because now all the cars have crashed and are in a staying position. And if state is less than 0, then we just need to reset state to 0 because now the traffic will now be in a staying state. Now, if the current car is moving right, then we will increase state by 1 if state is greater than or equal to 0. Otherwise, we will just set the state to 1. So I think this is pretty self-explanatory because if state is already greater than or equal to 0, then we will just increase state, meaning increasing the traffic of cars moving right. And if the car's moving left, meaning less than 0, then we just need to reset state to 1 because now there's one car moving right. So let's go over this example real quick. We will start off the state as -1 because we will just assume that the cars are moving to the left. Because let's say that if we set state to 0, then if we have an L here, it will assume there will be a collision, but that's not the case. So that's why we just set state to -1 in the beginning. So first, the car is moving right, so we need to set state to 1. Now we come to L, so obviously there's a collision here. So we need to increase the result by 2 because it's state plus 1. And then we need to reset state to 0. Now that we are here, the traffic is moving right, so we just increase state by 1. Now that we come to S, which is a staying position, we just need to increase the result by state, which is 1, and then reset state to 0. Now that we have a car moving left, so we need to increase the result by 1. And now we are at our last L. It's moving left, so it will crash here. So we need to increase the result by state plus 1, which is 1, and reset state to 0, but it's already at 0. So we keep it at 0. And now that we have come to the end, we can return the results, and that's 5. So the time complexity will be O of n, where n is the number of cars in directions array because that's the number of cars we will iterate through. And the space complexity will be O of 1 because we are using constant space. So now let's get to the coding part. So first we will initiate result to 0 and state to -1. And now we will loop through direction. So for C in direction, C for car, and if the current car is moving left, then we want to check if the state is greater than or equal to 0. If it is, then we want to add by state plus 1 and reset state to 0. Now we will check if the current car is staying, so if C is equal to S. If it is, then we need to check if the state is greater than 0. If it is, then we will just add by state. Otherwise, if it's moving left, meaning if it's negative, then we just reset state to 0. And now if C is R, then we need to check if state is greater than 0. If it is, then very simple, we will just increase state by 1. If not, then we will set state to 1. After that, we can return the result. Let's see if it works. Okay, great. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.